Today I want to demo a library I've been working on these past couple of months called Racket GUI Easy. It's a declarative API on top of Racket GUI. It's still a work in progress, so I might make some breaking changes, but I would say it's at a good point where it's worth showing off. So yeah, let's just dive right into it. So if I require Racket GUI Easy, then I can declare a window with some text in it that just says hello world. If I run this, it doesn't really do much. It just it just built up a representation of what that window should be, right? It's like a window with some text in it. But then if I take that representation and pass it to render, then suddenly I get a GUI out of that. So I can take that further and I can make something that, let's say it includes a couple buttons. One has the label minus, and we're going to ignore its action for now. The other one has the label plus. Again, we're gonna ignore its action. Actually, let's make these print something. So button minus clicked and button plus clicked, right? So if I run this now here we have a GUI with two buttons and some text. Let's say we want to align these horizontally. So if I just use an H panel, that'll do it. All right, this is starting to look like something. Let's maybe make this say 0. Okay, and now when we click the buttons, we can see the text gets printed out. And so aside from these sort of representations of GUI elements, Racket GUI Easy also provides a notion of, easy operator, a notion of observables. So let's say the counter is an observable with an initial value of 0. So this at function is just a shorthand for creating an observable. And so let's just look at observables for a second. So if I just load the code in my REPL here and look at the counter, we can see it's an observable. And what observables are, they're kind of like boxes to which you can subscribe arbitrary functions to changes in their values. So if I, for example, add an observer to this counter v, and just make it say like observer1 saw v, and then maybe add another one, call it observer2, and then when I push a change to the counter, you can see both of the observers receive the new value. And so internally, Racket GUI knows how to dispatch observer changes to views that depend on them. And so, for example, I can take this counter and plug it into this text view, but first I have to map its value to a string. So this is the mapping operator, but I could have said obs map counter number to string just as well. Okay. And now we get the same GUI as before. Nothing really changes at this point. But now I can change the buttons to modify the counter. So this is going to be sub1, and this is going to be add1. So now when we click minus, it subtracts 1s from the counter, plus adds 1 to the counter. And so this is the updating operator, but we could have just as well called obs update counter sub1, right? So those two are the same thing. Okay, so I think this is pretty cool, but we can take this further. We can actually define a counter view, right? And we can just take this implementation right here and abstract over it, and now we can make two counters. Maybe one starts at 0, maybe the other one starts at 5. Right, and now we can drop that. And so now we've abstracted over our counters, and we have two counters in here. And then we can take that even further. But first, let me just change this a little bit. Whoops. And so this should call action with sub1, and then action with add1. Counter 1 is 0. Counter 2 is 5. And so we want to update counter 1. Oh, well, I guess we can just apply proc there. Counter 2. So this works exactly the same way. And the reason I made this refactoring is, as we'll see in a couple minutes here, we're going to want to pass in a mapped observable or a derived observable into the counter. And derived observables can't be updated. So it wasn't... It's usually not a good idea for custom views to directly try to change the observables that are passed in. It's usually better to take a callback like this. And let me show you what happens if you try to. So if we just take counter 1 and then we map it to a string, we get back a mapped observable, and then if we try to update it, let's say we add 1 to it, it'll throw an error. Okay, because it doesn't make sense to be able to update a derived observable, because what happens if you update it, but then the thing it depends on, the observable it's derived from, changes. Okay, so we have this. Now we can take this a step further and make it possible to dynamically create counters. So we can, for example, a panel, add a counter. So we can add a button to add a counter. It's not going to do anything for now. And we can define our counter's state as a list of pairs where the first element of every pair is the ID of the counter, and then the second element is its actual current count. Okay, and then let's just drop that for now. Let's define a function to append a counter to the state. So we might grab the next ID by adding 1 to the current max ID of the counters. And then we might just append counters list where we cons the next ID onto 0. Okay. Let's just drop that for now. And so if we append counter to a list with 0, 0, we should get a list with 2 elements. Whoops. What did I do wrong here? Oh yeah, I should apply max. There we go. Okay, and then we can append counter again. What have I done wrong now? Oh, whoops. list of lists of lists. There we go. Cool. And so now that could be the action we take when we click on add a counter. So just append counter. And then to display, whoops, counters, I can't type. To display our counters, we can use a list view, give it the counters, tell it what the key, that is, how do we map the entries in the list to the IDs of each individual counter. And because we're just using the first element of every pair as the ID, then that's just the car. And then it needs a function that creates the views for every counter. And so we just call counter. So the first element, the first argument passed to the creating function is the key of the element or the entry in the list, and then the second element is an observable of that entry. And so we need to take the coulter out of that when we pass it into our counter function. And let me just move that down here. Okay, and then for the callback, we're just going to take the proc, and, well, for now we're not going to do anything. But now if I open this up, let's see, why isn't it? Oh, okay. Let's make the window a little taller. And then let's just make this not stretch vertically. Okay, and also this guy. Now, there we go. So now if I hit this, we get new counters, but we haven't wired them up to update the state. So we can do that next. So let's see, let's actually just add a define update entry or update counter, counters at k, and some procedure. And then we're just going to iterate over all of the entries, and then if the car of the entry is equal to k, then we make a new entry by applying proc to the entry's coulter, right? Otherwise we return the entry unchanged. Let me just try this out in the REPL. So if we just have counter 0 with 5, counter 1 with 3, right, and then we try to update one of them, let's say it's counter 1, and then we sub 1, then counter 1 ends up with 2, and counter 0 ends up unchanged. Okay, and so we can come back here and update the counters. Update counter, counters k using the proc. All right. And so now we can dynamically create new counters that all independently change their own state. So yeah, I hope that was interesting. And I hope you try it out and let me know if you run into any issues. The repo contains a ton of examples, and I just pushed some documentation that should make it on the package server soon. So yeah, thanks for watching.